Hello, good morning. This is a brief little lecture looking at the biotic distinctiveness of oceanic islands for BIOL2462 Caribbean Island Ecology, part of the course in Natural Resource Management at the University of the West Indies in St. Augustine, Trinidad. So during this lecture, I want to take a look at oceanic and continental islands, and basically looking at the biotic differences between oceanic and continental islands and why there are biotic differences between the two. And we'll take a look at some of the differences between the two, some of the origins, some of the reasons for it, mainly by looking at the history of these different types of islands and how that history impacts on the different biotas which exist. So the first and most important part of how the biotas of oceanic and continental islands differ is their history, basically where they came from and what has happened to them in the past. Their origins are probably the most important thing when it comes to what sort of biota you have on continental as opposed to oceanic islands. And probably the most important part of the difference is that continental islands were once part of the mainland, so they were an integral part of the mainland, so they had a continental biota, they had a continental flora, continental fauna, whereas oceanic islands had never been part of the mainland, so they arose above the ocean, some distance from the continent, and they've never been joined to the continent. So the biota which exists on these oceanic islands must have arrived there by traveling over water. So that immediately places a big filter on the types of plants and animals that you can get on oceanic islands compared to continental islands. Right, so if we take a look at the Caribbean region, we can see by looking at the ocean floor what some of the origins of the islands were. Well, first of all, let's go back to the previous slide. One thing that we should note is how islands are made into islands, and basically this will influence a lot whether the islands are continental or oceanic islands. And there are two ways in which an island can be created. The first one is the island can be lifted up, so the land rises above the ocean. And the second way in which an island can be created is when the sea levels change. So the sea level goes down and creates an island. Now, the process which creates a continental island is usually the latter. So sea levels will change. So quite often a continental island is quite happily a part of the continent when the sea levels are lower. But as soon as the sea levels rise, the piece of land which forms a continental island gets cut off from the rest of the mainland. It is still on the continental shelf, but that continental shelf is now underneath water. So that island is when the sea levels are lower, is maybe the high points on the coastal plain of the continent. So, for instance, Trinidad's northern range, when the sea levels were lower, were a set of hills set in a coastal plain on the continent. So when the sea levels rose, the sea flooded into the Gulf of Paria and up the Columbus Channel and basically cut off the northern range and much of the southern part of Trinidad, which was a bit raised, and created a continental island. Okay, now oceanic islands are usually created by tectonic activity, by volcanoes, by upthrusting, and that's usually some distance from the continent. So sea level fluctuations don't really influence whether the oceanic island is joined onto the continent or not. Okay, so oceanic islands tend to have their origins in land rising, land building, and it's the oceanic island, the ocean level fluctuations don't really have much impact on whether the oceanic island is an island or whether it's part of the continent. Okay, now what makes ocean levels rise and fall, and has it happened very much in the past? I think you all probably know what makes ocean levels rise and fall. It's mainly to do with glaciations. When the Earth gets colder, for whatever reason, we don't really know for sure exactly why the Earth gets colder. It's a very complicated process. When the Earth gets colder, however, the ice caps at the poles tend to expand. As they expand, the amount of ice and therefore water above the general surface of the ocean increases. So that means water is actively sucked out of the oceans and locked up in those ice caps, okay, which are effectively removed from the oceans. And this has a dramatic effect on the ocean levels around the world. So ocean levels at the height of the last glaciation were approximately 100 meters below what we see today. That sort of fluctuation means that many of the islands, continental islands today, were part of the mainland. That includes Trinidad. Okay, this happens with has happened with a fair amount of frequency over the past few million years during the Quaternary period, where there have been successive glacial periods where the Earth has been colder, the ice caps have expanded, contracted, the sea levels have risen and fallen. So a lot of the continental islands on the shelf have become isolated, rejoined the continent, become isolated once again. At the moment, we are in what is known as an interglacial, where the climate is warm, so the ice caps have contracted so that the sea levels have risen. So we're getting a lot of continental islands. If we keep that in mind and we take a look at the picture of the sea floor of the Eastern Caribbean, we can see the continental shelf. If you look at the cursor on the screen, you can see Trinidad there, some of the Dutch Antillean islands, the ABC islands, Aruba, Bonaire and Curacao. And we can see the Lesser Antilles here and the Greater Antilles here. Now, as you can see, this is the continental shelf, the edge of the continental shelf here. Okay, there's a bit of a basin there, but generally this is the continental shelf. So during the last ice age, all of this fringe would have been land. These islands probably joined on as well. Okay, the Lesser Antilles, however, are on a ridge on their own, Barbados on a ridge on their own, so they wouldn't have been joined onto the continental shelf. Okay, there's still a channel there. Okay, so Trinidad and Tobago are effectively continental islands. Lesser Antillean islands are more oceanic islands, and the Greater Antillean islands are also oceanic islands. They have been isolated. They haven't been able to benefit from the sea level changes in that they've been too far away from continents to be able to join onto continents and receive all that continental flora and fauna. Okay, so what does this mean for the biotic differences between oceanic and continental islands? Okay, three main things: species richness, harmony and endemism. First of all, species richness. Species richness is generally lower on oceanic islands. Okay, so continental biotas are the most species rich. It's got the largest area of land, So you can support many more populations of many more species. So you've simply got a lot more species which are able to resist extinction. So species richness tends to be much higher on continental islands and lower on oceanic islands. If we look at Trinidad and compare it with Jamaica, which we will on the next slide, generally the species richness tends to be higher on Trinidad, despite the fact that Trinidad is half the size land area of Jamaica. The second thing in which biota differs between oceanic and continental islands is to do with the ratio of taxa to one another compared to the baseline continental proportions of species between the different taxa. And this is known as harmony. Continental islands tend to be in harmony with the continental biota, whereas oceanic islands tend to be in disharmony with the continental biota. And the reason for that is because the oceanic island biota has to pass through the filter of being good dispersers to be able to exist on these oceanic islands. So you're immediately going to have a subset of the biota from continents on your oceanic islands. Okay? And that subset are going to be the plants and animals which can disperse well and reach these oceanic islands. So in our little graph here, we can see that birds are in pretty much the same sort of ratio with continental floras, whereas amphibians are on islands tend to be much reduced compared to mainland or continental species of amphibians. The reason for that is because amphibians do not disperse very well across salt water, whereas birds do, because they can fly. Okay, so the ratio of amphibians, island amphibians to mainland amphibians, is very biased towards the mainland. Okay, so this comparison of species in the different taxa is very disharmonic. Okay, so the island taxa are in very different ratios compared to the continental taxa. If we compare that to a more continental island, it's a much more harmonic distribution. Okay, because those continental islands were joined to the continent maybe in the order of 10,000 to 15,000 years ago, their biota is still pretty much in the same sort of ratios. In other words, the plants and animals on that island are still descendants of that continental biota which walked across, basically, didn't have to disperse across water, and therefore the ratios of the different taxa are the same. The amphibians on these continental islands are in still pretty much the same ratio because they haven't all died out or anything. All right, and the third main biotic difference between oceanic and continental islands is endemism. Endemism refers to whether a taxa or a species occurs in a particular area and nowhere else in the world. Okay, so you can say a species of plant or animal is endemic to Trinidad. That means it occurs in Trinidad and it doesn't occur anywhere else in the world. Okay, now endemism tends to be higher on oceanic islands. So oceanic islands tend to have a greater proportion of their species occurring on that island and nowhere else. And this really is a function of the fact that island species tend to be isolated from continental populations because of that isolation, they tend to turn into species which are unique and different. Okay? The mutations which occur in island species populations are not shared with the mainland, so they give rise to new and unique forms. And that can happen fairly quickly on oceanic islands within a matter of 10, 15,000 years. Well, actually probably a bit longer than that. But generally endemism is higher on oceanic islands compared to continental islands, because continental islands have only been around for about 10,000 years, so there hasn't been as much time for new and unique species to develop. There hasn't been enough time for different mutations to build up in continental island populations and to make them new and distinctive. So what does this look like? Okay, well, let's compare Trinidad and Jamaica. Let's take a look at the plants and the reptiles and amphibians. Remember that Jamaica is twice the size of Trinidad. So Trinidad is about just under 5,000 square kilometers. Jamaica is over 10,000 square kilometers. So generally it will have more species. However, when it comes to species richness of plants, Trinidad gives Jamaica a pretty good run for its money. It's got about 2,160 species. Jamaica has 3,582 species. Okay, so Trinidad, despite its smaller size, has a comparable number of plant species to Jamaica. The big difference between Trinidad and Jamaica is that Trinidad only has 2.5% of its plant species endemic. Jamaica has over 25% of its plant species endemic. So over 25% of Jamaica's flora is found in Jamaica and nowhere else. Okay? Only 2.5% of the plants in Trinidad are found in Trinidad and nowhere else. Okay? So this reflects Jamaica is an oceanic island, Trinidad is a continental island which was joined to the continent of South America maybe 10,000 years ago. So it tends to have much fewer unique species which are found nowhere else. Generally, the species which are endemic to Trinidad are the ones which are found up in the mountains. So there's a real hotspot of endemicity in the plants in Trinidad up in the northern range. And this makes sense because that northern range probably has been more functionally isolated from similar sorts of habitats on the mainland, even when the lowlands of Trinidad and the lowlands of South America were joined together. The northern range probably formed a range of hills which were more moister, wetter, okay? And then you had to go down into dry forest in the lowlands before you reached another range of hills, which in the case of Trinidad would have been the Paria Peninsula in Venezuela. Okay, so those mesic habitats have been separated longer. Okay, and therefore there are more endemic species in the northern range compared to the lowlands of Trinidad. Okay, if we look at the reptiles and amphibians in Trinidad compared to Jamaica, the difference is much more stark. There are 85 species of reptiles and amphibians in Trinidad and only 61 in Jamaica, despite the fact that Jamaica is twice the size of Trinidad, still has fewer species. Of those species, there are no endemic species of reptiles and amphibians in Trinidad. In fact, I think this is incorrect because we have that golden tree frog, don't we, in Trinidad, which is endemic to Trinidad, found nowhere else. But the proportion of endemic species in Trinidad is very low anyway. Whereas in Jamaica, over almost 3/4 of the species of reptiles and amphibians in Jamaica are in fact endemic. Okay, So they are special and only found in Jamaica. So again, you can see the difference, the influence of this oceanic island compared to a continental island. Let's move on now. Okay, what's going to happen with time with continental biotas and oceanic biotas? Now, this is if we imagine that things don't change into the future. In other words, there isn't another ice age and the continental islands are not joined to the mainland once again. Okay, there isn't any massive changes in the global climate and so on, which we know is going to happen. So this may screw up these predictions a little bit. But generally, what will tend to happen with time is that oceanic island species richness will increase as more species colonize and you get more species on the island, up to the point where the size of the island will dictate the number of species which can survive on that island. The oceanic island biota will therefore become more harmonized with the continental biota as more of the species less able to disperse finally do make it onto the oceanic island. Oceanic island endemism will increase with time as mutations on these oceanic islands build up. Okay, so what will happen with continental islands with time? Continental islands will decrease species richness with time as species colonize with less frequency. So when the continental islands was joined to the rest of the continent, species could colonize the continental island easily, very quickly, because they just had to walk across. Okay, when the continental island got cut off by the water, that colonization frequency decreased. Okay, therefore, if a species went extinct on that continental island, it is less likely to be replaced. Okay, so the number of species on these continental islands will begin to fall. And this process is known as a process of relaxation. Okay, so continental islands are thought to decrease in their species richness over time. Okay, the continental island biota will become more and more disharmonized with the continent biota as the species which are more vulnerable to extinction, those ones which are larger, need more area to support a minimum viable population size, they become extinct and they are not replaced by colonization from the mainland. Okay, so things like the big cats on Trinidad, for instance, became extinct, okay, after Trinidad was separated from the mainland, and they have not recolonized. So in that way, the mammal taxa in Trinidad is becoming in more and more disharmony with the continental, becoming continental biota. So it's becoming more and more disharmonic. Continental island biota endemism, however, will increase with time, but that will take much more time. It'll increase slowly as the mutations build up. Something like Madagascar, which represent a continental island, gives you a good idea of how endemism can build up over time. Okay, Madagascar was a continental island. It was joined onto the continent of Africa, but it separated off millions of years ago. Okay, and plate tectonics forced Madagascar away from Africa, so it essentially became an oceanic island in that it wasn't joined on to Africa with fluctuations in sea level, mere fluctuations in sea level. So it built its own biota, very distinctive biota. Mutations built up, and the biota of Madagascar went a separate way in comparison to the biota of Africa, the African mainland. Okay, so the biota on Madagascar is something like 90% endemic. Okay, despite the fact that it was a continental island, now it is acting much more like an oceanic island because it has been isolated for such a long time. It's got very high endemism. For an equivalent area of the African continent, it probably has a slightly lower species richness. Okay, so hopefully from this lecture you'll get a pretty good idea of how continental and oceanic biotas are different, and how over time that difference will probably decrease as the biotas of the two types of islands change. Okay, thank you very much. Bye-bye.